Have you ever seen a robot arm suddenly stop, freeze, or move in an unexpected way when it is trying to perform a task? It might look like the robot is confused, but often, it is encountering a fundamental challenge in its movement called a kinematic singularity. These moments are critical to understand for anyone working with robotic systems. Kinematic singularities in robot arms are specific configurations where the robot loses one or more degrees of freedom for its end effector, meaning it can no longer move freely in all directions, or it would requiring infinite joint velocities to do so. Essentially, the robot's ability to move precisely becomes temporarily impaired, much like a person getting their arm locked in an awkward position. The core reason behind these singularities lies in the mathematics of robot motion, specifically the Jacobian matrix, which relates the velocities of the robot's joints to the velocity of its end effector. At a singular configuration, this matrix loses its rank, meaning its determinant becomes zero. This mathematical condition translates to a physical limitation, where certain end effector movements become unachievable, or small desired end effector movements necessitate extremely large, often unattainable, joint movements. It is an inherent property of the robot's mechanical structure. To manage and mitigate singularities, engineers employ several strategies. This includes careful trajectory planning to steer the robot's path away from known singular configurations. Robot designers can also add redundant joints, providing more flexibility and alternative ways to reach a target without entering a singularity. Furthermore, implementing robust control algorithms that anticipate and react to proximity to singular points helps maintain stable operation. Understanding these problematic configurations is crucial, as there are distinct types. For example, a common occurrence is the wrist singularity, which happens when the axes of a three-roll wrist become aligned, causing a loss of rotational freedom. Another is the shoulder or arm singularity, typically found when the arm is fully extended or fully retracted, limiting movement in certain directions. There are also reach singularities, which occur when the end effector is at the maximum or minimum reach limit of the arm. Ultimately, recognizing and planning for kinematic singularities is fundamental to designing, programming, and operating robot arms safely and efficiently. By understanding these inherent mechanical limits, we can develop more intelligent and reliable robotic systems that perform complex tasks smoothly and predictably, avoiding those unexpected freezes and movements.
If you love robotics, like, subscribe, and keep building with us.